Have you ever played with Lego building blocks? I'm sure you did. But how many of you are still playing with them? Probably not many. During my PhD, I'm still playing with Lego building blocks, but the one I'm using are a little bit special. I'm researching in a field that is called synthetic biology, and you can consider it like the combination of biology knowledge with an engineering approach. One of the main aims of this subject is to build structure for novel functional materials by using biological molecules like DNA, proteins, but either entire viruses or bacteria. How we can do that? We exploit a process that is called self-assembly. That is basically the capability of components to recognize each other and bind. Can you imagine that you can take your Lego building blocks, fit inside a basket, shake, and have your structure done? I know, it sounds really complicated in terms of design, architecture, and plans. But what we can have with this is very short time of production, low costs, and environmental sustainability. Another strength of this method is the size of the components. In fact, proteins and other blocks are in the nanoscale. That means 1 billion of a meter. So very, very small. This is very useful to build up structure for very small devices and also show properties that are not available in nature. But let me give you an example. This is M13. This is a very small virus. It's long 1 micron and is wide 6 nanometer. He likes to infect bacteria, so I'm safe. And I'm trying to make several structures with it, and the most challenging is an array on a surface of this virus that should be able to bend the light around it, reflect what is behind, producing an optical effect, invisibility. I know it sounds crazy, but another thing I'm working on is my M13 sponge, that is a multifunctional structure that should be useful for really light batteries, supercapacitors, gas or liquid absorbers, and sensors. So these are just few examples of what is possible to do with synthetic biology, just by using the bricks and the technologies already available in nature, plus a bit of imagination. This is for future, for novel materials and for environmental sustainability. Thank you very much.